basically is, it's two things that are connected. So a relation is two things that are connected, basically. So here, let me write some relations here. All right, so let's say this. I've got these weird, wacky, oop, that's not it. Let's say that I have these weird, wacky braces right here, right? That's not it either, man. I don't want to type it in, man. I'm crazy. Okay. And within these weird braces, I got parentheses, and I get these values. And let's say 2 and 0. You guys can totally take notes on this because it might help you out. 3 and 6. And then I've got this other last relation here of 4 and 4. Huh? What circle things? You telling me I'm making a circle? You might think that, but here's the whole thing that I want to get into. When we start talking about things that are, oh, we've got relations here, right? Relations, what really we're talking about is things that are connected. I've said that, but what I'm really also saying is, guys, sometimes in math, we've got a lot of numbers or data that typically or don't necessarily make a lot of sense. Just because it's data, it's a lot that's thrown at us. But if you can create a visual out of those numbers, you might be able to make more sense out of it. It might be able to tell you something else. And just because, guys, I have these numbers written in the braces here, and that 1 is connected to 10 or related to 10, well, it doesn't necessarily mean that 2 and 0 are connected to 1 and 10. And the points 3 and 6 aren't necessarily connected to these previous points. So the first thing we're going to do is I have shown you a set right here, a set of values. However, let's turn that into another way of visualizing or expressing the same information. The way I'm going to do that is I'm going to create a table. Oh yes, the best table you have ever seen. Probably better than your own dining table. Dining table. You should have laughed when I said that, Alex. That's Mr. Gillespie, you're so funny. Okay, so here we go. Here's another way of expressing this information. So I've got my, I'm going to change the color here. Not, oh, okay. So I'm going to say, hey, these are going to be my x values. These are going to be my y values. And let's start with all the x's. Well, my x values are the 1, the 2, the 3, the 4. Okay. 1, 2, 3, and 4. So I've got 1, 2, 3, 4. And now my 1 is connected or related to a y that is equal to 10. And my 2 is connected to 0. 3 is connected to 6. 4 is connected to 4. So as you can see here, hey, these are not necessarily connected to one another, but still, this is just one way. We call this our table, right? Got my table here. Had my set of numbers above. I'm just seeing a hand up in the air. I'm not seeing a face, but I'm willing to bet it's Jacob Hill. What's up, Jacob? What's that? Why do you think it's an 8, buddy?
Because that would make more sense.
10, 8, 6, 4. Smart man. Good job. And my question for you, is, were you sure that it wasn't supposed to be an 8?
Wait, was it supposed to be an 8?
Yeah, it turned into an 8.
Cool.
Jacob, way to keep your eyes open, buddy.
Yeah, James.
Okay, hey guys, but this isn't the only way to express this information. There's another way, and we're going to call it mapping. I could actually create a map for these. I'll show you how to do that. Huh? Probably, I just don't want to.
How do you make a map?
I'm going to show you how to make a map. Alright, so this is my table to the right. And now I'm going to, or the left, and now my map's going to be to the right here. And I'll stick with orange for writing the numbers. So this is my mapping setup. And my mapping tells me this. Hey, 1, 2, 3, 4, 10, 8, 6, 4. So over here, we change colors now. My 1's connected to 10. My 2's connected to 8. 3's connected to 6. 4's connected to 4. Neat. So I've got another way, it's called mapping, where I can actually use arrows to tell me, hey, which number is connected to the other. But there's still another visual that I can create, and that visual, I'll move over to the right here, we call, that visual, we call a graph. So the graph, draw that up here. I'm just going to use green still, guys. And along the bottom is my x-axis. So these are my x values. Along the side here, vertical, are my y values. So, oh, I don't know, I'm going to say here, I'm going to erase x-axis, by the way. I'm going to say, hey, this is going to be 1, 2, 3, 4, we'll call this 2, 4, 6, 8, 10. So 2, 4, 6, 8, and 10. 1, 2, 3, and 4. And now the next thing that I want to do is plot my points. And I'll use yellow here. So 1 and 10 are connected. They're related to each other. And then moving along, I've got 2 and 8 that are connected. And 3 and 6 are connected. And 4 and 4 are connected. Hey guys, if you look here, you'll notice, hey, these points, they're sort of discretely plotted on the graph. They're not connected with a continuous line. So we call this a discrete graph, by the way, because they are discretely placed on the graph and not connected one to the other. Okay, so that is how you actually show multiple relations. What's up, buddy?
How do you know when to connect them or not?
How do you know to connect them or not? That's a great question. Well, in this example, all the information that I'm given are these points. I'm not told that they're connected. Is that making sense? So all that I know is that I have these discrete points, and so that's why I don't connect. All right? And another thing here, guys, here's another good thing to think about, is when I get to my x down here, usually our x, when we use a continuous, guys, when we use the continuous line on the graph, what's the x-axis usually titled? Who said that? Gavin, say that louder.
I didn't say.
You said time. You were such a genius.
Carter.
It is Carter.
Oh, Carter.
He said Alex.
Carter.
Oh, he said stop.
Okay, so it's time. Usually you have time. So hey, Hayden, to answer your question, time's usually continuous. Time marches on. Think of it like a stopwatch. You hit start, you start recording. Every single second has a value. This, all I plotted are specific points, 1, 2, 3, and 4. So again, I use discrete points from there. Yes.
So get the what? Wouldn't that be like height or?
You don't know. So you've got, but to think about it, yeah, why am I using discrete values rather than continuous lines? you've got to think of your independent and dependent variables. Here, I've not given an independent or dependent variable, so I can't say it's time. Therefore, it's got to be discrete. Yes?
But isn't like, okay, isn't independent variables hold the y-axis and independent?
Let's worry about that later. I got to move on. That's a good question. It's a good question. Okay, so we're going to move on to the next one. That whole section we were talking about showing multiple representations for relations, Trevor. But now we're going to move forward to finding the domain and range of relations, or just the domain and range. So here we go. I'm going to pull up our next set of information here. Let's say that, I need to get a number line here. Let's say this, boys and girls. Got my tool selected, cool. Okay, so I got my number line right here. And on this number line, I'm going to title let's say, hey, I got point 1, 2, 3, 4, 5, and 6. And I'm not going to draw an arrow on this, but you know this line can continue on. 1, 2, 3, 4, 5. And I am going to change these units. Rather than saying these are 1, 2, 3, 4, values worth 1, 2, 3, 4, they're going to be worth 2, 4. They're going to be worth units of 2. 6, 8, 10, and 12. And over here I've got 2, 4, 6. That doesn't look like a 4. I'll go and fix it. 4. It still looks like a 9. Okay, there we go. 4, 6, 8, and 10. So here are my values here. And now let's go ahead and graph them, Trevor. So the way to do that, I'm going to say, hey, this is what I have. At value, we'll just put this somewhere in between 2 and 4. And I'm going to go up to 8 here. And I'm just going to mark this place. And let's say, hey, down over to, I don't know, let's go to 8 and then down to 4. So somewhere right about here. Okay. Well, let's say that I've got a shape of my line going from point to point. So I have these points, and what we're going to look at is how do I actually write the domain and range for these points. Well, guys, the domain here, the domain really all it is it's all the allowable x values, all allowable x values.
What were the points given?
Well, we'll talk about that in a second. So let's actually graph, well, we have it. Yes, ma'am.
If you want to say the x values that you make it as compound
Okay, let's find out. That's a great question, Peyton. Okay, here's what she's asking. She's saying, hey, because, can you ask that again? Cody. Yeah, to show these x values, let's find what the domain actually is. Well, over here, if I move across the x-axis, 2, 3, and 4, in between 2, and if I go to 2, and I were to scroll my finger up or my pencil up and go all the way up vertically, hey, it doesn't really run into the point. So I'm going to move out over to 3 and say, hey, does 3 run into it? And yeah, 3 actually runs into this point. So what I'm going to do is I'm using a purple pencil to say, hey, 3 is a point of a value for x. And also if I move all the way down to 8, I would say, hey, 8 actually is a value for x. But when I move to 9, 9's not included. 9's not a value of x. So I know that, hey, x, it equals 3, or yeah, it equals 3. So x equals 3, but it's also greater than 3 because if I move to 4, 4 is also x value, 5 is also an x value, 6 is also an x value. So what I'm going to say here is that, hey, let's get a brighter pencil. But 3 is less than or equal to x, or x is greater than or equal to 3, but it's also x is less than or equal to 8. There we go. So that's my domain, guys. That is how I solve for the domain. However, I can also solve for the range. And to solve for the range, if the domain is all the allowable x values, guys, what do you think that the range is? Yes, sir, Alex. So the range is all of the, how Trevor pronounced it, y values. All y values. So now, going back to, let's use blue this time. So now, if I were to, now my y values for my range, I'm going to go up to 2, and I'm going to say, hey, if I ran my pencil across the 2 values of y, no, 2 is not a y value. So let's move up to positive 3. Positive 3, a y value. Yep, it looks like 3 actually runs into it. So what I can do here is run my pencil along, and it's connected. And then if I keep moving up, because 4 is going to be connected, 5, 6, 7, 8, and it is 9 connected, well, let's find out. Well, yeah, 9's actually connected, but if I move up to 10, 10 will not be connected. So therefore, all of my y values are going to be the following. I'm going to label this. Hey, y is greater or equal to 3. So 3 would be less than or equal to y. And y is less than or equal to 9. So I'm going to do one more thing. So my range along the y values is going to be all of these points right here between 3 and 9. Grabbing my purple, my domain, all the x values are going to be between 3 and 8. Okay, so that's how you find the domain and range and write about it. Let's go on to another problem here, guys. Let's look at this. Yes, sir. You cracked me up. Okay. I've got some problems. If we get to the problems, yeah. If we get to the problems, I'll let you.
Really appreciate that.
Okay, guys. Here's what we're going to do. I'm going to just kind of backtrack. No, I'm not. I'm going to move forward. I was just going to say, hey, this is what we did, but you already know what we've done. We're going to move on to identifying functions here and actually saying, hey, what is a function really? And the values I'm given, are they actually functions? So the first thing I'm going to tell you here is a function. I'm going to get off the brush and get us to, let's use blue. That blue is cool. So a function, what a function really is, it says, hey, for all my x values, or for each x value, I can only have one y value. For each x value can only have one y value. So for each x value that I have, I can only have one y value. You're awesome, Trevor.
I just want to use it.
I know you do. I'll get you there. Okay, so for each x value, you can only have one y value. So let's go on and actually look at a problem here. I'm going to create a little table, and you just keep taking deep breaths, buddy. So let's create this table. I'll still use the same blue here, because that blue's cool. And I'll go back to a pencil, and let's get some labels started here. So let's say one. We'll do this. And let's say that, hey, I'm selling shoes. I'm a shoe salesman. You guys know that before I started teaching, I was a shoe salesman?
Oh,
I worked at Runtex. I still work for Runtex. Okay, so here's the data that I'm going to show you. I'm going to change our color real quick. Let's say that this is going to be labeled my dates. Pairs of shoes sold. Pairs sold. Oh yeah, tons. Pairs sold and total sales. And that's real sloppy. Let me clean it up for you guys. I'm going to say sold and total sales. All right. So let's just say, what's today's date? The 18th. So let's just say 3 days ago, or 2 days ago. Let's say that on 10/16, I sold 52 pairs of shoes for a grand total of, I don't know, $245. Let's just say $245. And then on 10/17, which was yesterday, I sold a grand total of 62 shoes for, let's say like $980. And then let's just say, this was the 17th, guys. And then let's just say, hey, on the 18th, let's just say I sold 52 shoes again for a total of, let's say $640. Now, I heard a couple of you already saying, hey, wait a second. On the 16th, prices, your total sales are way too low. If you look up here on the screen, dude, the sales are way too low. But, hey, here's the deal. The shoes that are being sold on the 16th may not be as expensive as the shoes sold on the 18th. So what I'm going to do here is let's write the domain and range out. Let's find out what the domain and range are. So again, my domain are all of my x values. So my domain here are going to be my pairs sold. Again, remember, domain are x values, and x values are independent variables. So shoes sold. So I'm going to say, hey, I sold 52, and I sold 62 on another day. And that's all I'm going to write down. I'm not going to write down this other 52 because we don't rewrite the domain. Now my range is, what did we say? 245, 980, and 640. Okay. Now from here, let's go ahead and do some mapping again. Mapping's kind of cool. And what I'm going to do is I'll just scroll the screen down just a tad. And get a cool shape here. Oh, don't want to do that. How are we on time, guys?
We have 10 minutes.
Perfect. So here are my values here. And here's what we're going to say. Hey, my domain's going to be the left part of the map. So I'll say this is my D, this is my range. So 52 and 62. I've got 245 as my value, 980, and also 640.
So why don't we include 52?
Well, I already have 52 written, so I'm not rewriting it. And you're going to see why in a second. Ben, what's up? Hold your thoughts because we got 10 minutes and I need to get this point across to you. It's vital. So here, let's go ahead and map these points again. I'm going to use, let's do yellow because it'll stand out here. Okay, so 52 automatically, it maps to the 245. I already know that. But 52 also maps down to my other value of 640. And right from here, you automatically know that, hey, guys, Actually, in 62, I could also say, hey, 62 goes to 980 right here. So it maps to 980. But once you see the values of 52, this x value, guys, to be a function, what do you have to have again? Only one x value per y. Each x value has only one y value. Well, you know that your domain, your range is the y values. So how many y values does 52 have? It has 2. 52 has 2 different y values, so you know that, hey, this is not a function. And I can actually go back to the original chart, and on the original chart, do the same thing. Let's change that color. 52 here actually drops down to 640 and 245. Hey guys, not a function. It doesn't work because there are 2 y values for the x value of 52. This pairs of shoes sold. Okay, Trevor, let's see here, buddy. Let's see if we got time to do this.